Welcome everybody. It's not fair having to follow Tanya. It's one thing I'll say. It reminds me of a time earlier in my career when I was speaking at a IEEE meeting in San Antonio, and they said, okay, when they're getting ready to introduce me, they say, okay guys, like, have we got something great for you next month? Right? We're moving to a bigger venue because we've got Bjorn Strustrup, the creator of C++, coming out. We're like, ah! Right? And today is Dan Cornell talking about some security stuff. So at least in that case, I got to talk first. Now I've got to be in Tanya's shadow. A little bit of background on me. That's what I look like with an actual haircut and a coat. And I'm one of the founders and the CTO of Denner Group. And I guess what's important on here is I'm a software developer by background. Started with Java in the mid to late 90s, a lot of server-side Java. Spent in the early 2000s some time with the earlier .NET stuff, but really for the last 15 years I've been focused on helping organizations deal with the security of the applications they're developing. And so from a perspective standpoint, I come at this from a developer's perspective who's come to security as opposed to someone from a more traditional like pen test background that is now looking at web and mobile and cloud native applications. So agenda-wise, we'll talk a little about the good old days and then talk about some of the interesting things that we've seen in the ways that organizations are developing and deploying software, specifically cloud native applications. And the point of this talk is really just for me to relay things that we've seen in how we've had to evolve our assessment practices to deal with the way that organizations developing software has evolved. And I was joking, I was talking with a couple of folks yesterday, and they asked, well, what's the answer? And I was like, well, no, the talk just lays out the problem. At the end, I say like, so what are we going to do, folks? Well, what's the answer? So I'll talk through a number of things that we see and also talk about some of the things that we've seen in the communication of like how you characterize the things that you find during assessments. And we'll see if we have time for questions. If you have a question along the way, please raise your hand. I think we've got a little bit of a squish schedule, but I'll try to get answer any questions that people have. I realize I've been in this industry possibly too long because I've started putting slides in talks that talk about the good old days, and that may mean that that I've officially become a curmudgeon. I don't know, but I hark back to the good old days where you had an application, right? It was a web application. You've got users and the bad guys on one side. You got a database on the other side. You've got your application here, and for an assessment, right? You give me a URL and a couple logins. I'll just like blast App Scanner, Web Inspect at it, clear out the false positives, do our manual pen testing, based on the OWASP ASVS or whatever methodology that you had, or if we had the source code, like stuff it through check marks or run Fortify or whatever against it again, clear out false positives, and then go through and do your manual checks, according to whatever checklist you had. And it was fun work and it was exciting work, but it was comparatively very straightforward. And when you're done, you just generated a PDF. Secure emailed it off to somebody, and then you're like on to the next, on your next responsibility. And I think there's, as I said, I'm going to talk a little bit about some things that we've seen evolving with reporting. I think there's a lot more to be discussed there. We're not going to have time to drill into that as much as I would like to. Because what I want to focus on is kind of what we've seen in the way that organizations develop applications and the implications that has forced us to have to take as we've looked to start evolving the way that we look at doing assessments for applications. So we look at the more interesting new days. This is a architecture diagram that got spit out by we built some technology that auto draws threat models for you based on like agents you put on systems. which is something that we're just kind of playing with in the lab. And I installed this on our ThreadFix product, and looked at it. And it shows you, hey, here's all the communications that it's got going to different places. And I looked out and I said, oh, okay, I understand why it's communicating out to this server, out to this server, out to this server. Yeah, it's collecting data from those servers. That makes sense. There's some web connected stuff that we have the ability to do now. And I looked through and I understand that connection. I understand that connection. Why are we talking to these two web constructs? Right? So I went to the architect and he's like, oh, we needed to do X, Y, Z, blah, 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 whatever. Right? And so even with the product that I'm pretty familiar with, right, when we looked into it to see what are all the things that this thing you're talking to, like there are areas that I didn't know about, which I found to be slightly scary, but also very interesting because it echoes the things that we've seen, looking at the more modern applications that organizations have brought to us to do testing on. Even more interesting new days was this was an application for a media organization, and they had again, they had most of the application was in AWS. It had a web front end. It talked back to a couple of different microservices to do different things: the user service, content service, location service. Also talked out to various S3 buckets. That's great. Used Amazon Aurora for database. Also had hosted MongoDB that we couldn't quite exactly find immediately where that was at. So that's raised some question marks. And in talking through this with them, and they're like, yeah, and the chat is hosted at Rackspace on a dedicated server. And we're taking notes. We're like, right, chat hosted on a Rackspace cloud server. And they said, no, it's on a dedicated server. I was like, dedicated servers? Like, who's using dedicated servers these days? And so I envisioned, what did the provisioning of this server look like, right? Was it the reverse of the scene in Raiders of the Lost Ark, right? Where somebody writes on a scrap of paper, like, need dedicated server, 8 core by whatever, however many memories, put it in one of those banker tubes and like screw the end shut and like, and then it goes down like to the sub basement. Somebody gets this, like, oh, we need to go get a server. Okay, roll the cart out, take the dusty Dell box off of the thing, and put it on the cart and like wheel it back to the one of those industrial elevators. I don't know what this scene looks like, but that was really interesting to us to see, this application, again, very modern application where it had web front end, it had microservices, it was using different cloud constructs, it was talking out to a cloud provider that nobody really knew a lot about, and as always, when I hear something from a client, like, not all the time, but from time to time, I'll have the reaction of, well, that's stupid. Why are they doing that, right? And always. I'm always wrong, right? They always have a reason, and it's always a good reason, right? And Wendy Nather has talked about this a lot, in some of her blog posts and things like that, where everybody likes to make fun, and security maybe like scoffs at things a little bit too often, because the reason it was run on a dedicated server is that was the only configuration that the vendor would support. They said, for whatever reason, performance reasons, correct or not, if you want vendor support for this, it has to go on a dedicated server. They wanted the vendor support. Oh, okay, there we go. So that was a mini lesson that I got out of this, is like every time my reaction is like, wow, these folks are doing something stupid, I'm universally wrong, because they always have a reason. And when you look at that in the context of the requirements being placed on the dev team and the operations organization, like 100% of the time, it's a completely valid reason, right? There may be negative aspects to it, but it's always something that it's always something that is justifiable, or where you can look through the history and say like, oh, okay, that makes sense. So what changed over time from the easy days where you could just blast away at something, work through your pen testing or your assessment checklist, to now where for certain security people or folks that haven't maintained their skills, it's like 2001 with the monkey and the obelisk, and what is this new thing that we're seeing here? I think it's important to start and look at the why. Why has the way organizations developed applications, why has that changed over time from these monolithic giant applications, web server, database server, maybe talking to one or two other things, to include all this more complexity. And like for all the pen testers out there, it's not so that you get to like go to conferences and learn cool new things, right? Unfortunately, that is a side effect in a lot of cases of, or an implication of the things that changed. But what we saw in looking across organizations that we're dealing with is marketing overuses this or kind of beats this, beats this term to death, but this concept of digital transformation, right? Where organizations have to really face risk if they don't move their business to embrace a lot more of a digital approach. And a great example of that is, from talking to my business partner, John Dixon, he contrasted 2 trips he took. One where he flew on the airline, and as he landed, he got a text from the rental car company saying, hey, your car is in this spot, you just need to show up, go here, drive out, show your driver's license, and you're done. Versus another trip where landed, saw nothing from the rental car company, went to the rental car, had to go to the desk, they showed him finally to his car. It turned out that car, the license plate was expired, so they had to go get another car, and then they had to wash that car first, and it was just this really, really negative experience. And so you can see the contrast between, in the first case, an organization that had their act together internally with all the systems tracking all these things, and they also had their act together with their business partners. So they knew this person's on this flight. When they land, what they care about from me is, here's what you're going to do with your car, right? So that integrated, so-called digital experience, versus an organization that didn't have their act together internally, to say nothing of being able to integrate their systems across their business partners to provide this really valuable experience to their customers, right? And so if you contrast these 2 experiences from somebody who buys a lot of plane tickets and rents a lot of cars, the risk that we talk about in security, right? Like all the risk that we talk about in LASCON or at Black Hat or at DEF CON, like that risk for the most part is crap from a business standpoint, right? The real risk to businesses is they're going to be out-innovated by their competitors. They're going to be just simply outrun and out-innovated by new entrants into their markets. And a failure to address that risk is an existential risk, right? GDPR fines suck. PCI audits suck, right? Breach, you're doing breach notifications sucks, right? What really sucks is having to go lay off tens of thousands of people because you zigged when the market zagged, right? And so that's, I think, an important thing to understand, is that from a business standpoint, they're not adopting these new technologies because they're cool, right? They're in an environment where they have to go faster, right? How do you go faster? As I read in an airline magazine, clearly the way to go faster is DevOps, right? We need to reduce the barriers between the development teams and the operations teams, and hopefully security gets included, right? When the culture changes to DevOps, you have to adopt new technologies to support this mission, right? So you see organizations that are making changes going from a monolithic architecture, I'm going to build an app to do one thing, 2 sets of microservices, right? I need the different parts of my business to be able to talk about what they're doing, but I need to be able to compose and recompose those parts of our business to create new products. I need to be able to innovate faster, right? And then that then has an implication for the technologies that get selected, right? We want cloud servers so that we can scale up and scale down, easily provision stuff, right? Developers want cloud services. So, hey, I don't want to run my own MongoDB. Can I just get that from somewhere else? That's fantastic. Right, we've got containers. How do we make it so that we can deploy this stuff and it works the same every time, right? And we can wrap a thing around it. Serverless, even better. We don't even have to have servers. We can just have logic that floats around out there, and somebody else has to worry about this. And adopting things like CI/CD pipelines, right? We need to be able to make new software builds and very quickly determine, is this build something that is acceptable to put into production or not? And so that's the context that we see with a lot of organizations, where they're from a very strategic risk management saying, we have this existential risk, and that's going to then flow down to how we build applications, right? And so what that then does to the security team is it says, you're either on board with this or you're going to get marginalized. So for all the folks that are frustrated with cloud transitions in your organizations, I get it. For all the folks that are frustrated with the way that developers are adopting new technologies at like wacky rates and doing all kinds of crazy different stuff and not standardizing, I understand that frustration, but I think it's really important to understand the context in which those decisions are being made. As an aside, right, for organizations, like if you couldn't make one big thing, if you couldn't make one big monolithic application work right, like what makes you think you're going to make, be able to make like 30 things that need to talk to one another work right, right? So that is one question that I ask a lot of organizations as they're kind of willy-nilly diving into the world of microservices, because everybody thinks this is how they're going to work, right? All happy and friendly together. Really the picture, especially when folks are getting started and understanding, it looks a little bit more like this. So the way that we've over time and working with organizations and looking at different applications, what we've kind of boiled this down to is something that I, for blog post and conference title purposes, have called like the A's, B's, and 4 C's of thinking about assessments for cloud native applications. So the first thing we'll talk about is an architectural bill of materials, and there's been a lot of discussion about software bill of materials. What I'm talking about is an architectural bill of materials for an application, and then we'll look at the 4 C's: code, components, compute, and the cloud configuration. Maybe we need 5 C's, or the 5th C needs to be lowercase. I don't know. So when you look at a software bill of materials, right, that's a concept that has come out of a lot of work, coming out of both the public and private sector. It's something where Josh Corman has done a lot of work in various roles looking at this. But the question is, I've got this software, right? I've got this individual piece of software. What is actually in the software that I'm shipping? What are the open source components, potentially other components, but just knowing when I shipped this software, what are the open source components we pulled in? What are the different versions? What version of the code that I wrote is in there? How do I know for a given build what's in that build? Right, and this is something that is really important. I mean, just from in general, I think that's something that is certainly very very sensible to want to know about your software, and especially when you look at the vulnerabilities that you get from your supply chain. Right, vulnerabilities in the components that you're using to build your software. That's a very important question as well, and that's something that we've seen as a software vendor. We're starting to get a lot more questions from organizations where they're saying, "Oh yeah, by the way, we need a list of all the open source components in your software because we want to like attach that as an appendix to the contract," or something like that, right? So as a software vendor, we're starting to see that. And from the really sophisticated folks, when we deliver that to them, occasionally we get questions back. Hey, for these 3 components, why haven't you upgraded this one? Tell me how you're using this one, and explain a little bit more about what this is doing in the application, right? So this is something that that organizations are starting to pay a lot more attention to. And I'll highlight 2 projects. One is Dependency Check, a OWASP project that does software composition analysis, looks for the use of vulnerable components. And a different but related project is Steve Springett's Dependency Track, that is really centered around how do we craft and track these software bill of materials for individual applications. Both really exceptional projects. But for our purposes, or for assessment purposes, as we look at these cloud native applications, the question that I'm asking, or the question that we're asking looking at this is, it's more even a broader question of, from an architectural standpoint, what goes into this application, right? So how do we know, how do we actually know what all the pieces are of the application? Not just looking at the individual microservice and the individual web front end, but how do we know all of the pieces that are part of this software? Because in the absence of that knowledge, how can we make any meaningful assertions about the level of security of that system as a whole, right? That's a really big problem if you don't know all of the parts of the system that you're using, which is why it's really interesting, again, from those interviews, finding out, hey, we've got this, all this stuff, and it's all in AWS, but we have this other provider, we've got a dedicated server. Okay, good. Well, now that's all part of the overall attack surface of this application. The same thing looking at our system. Hey, we're using more cloud components than, from a governance or from a security standpoint, at one point in time we thought we knew. So we learned more stuff about that. So with the architectural bill of materials, the question is, like, what are the pieces of the system that we're looking at? And being able to answer the questions of, what are the various parts of this system? What do they consist of? What are all the sub parts of this that it rolled up to? What is each part of this system supposed to do? And also very important, where are these pieces hosted? Because that's going to have implications. Again, it's if it's hosted in an AWS environment, it's hosted in Azure. That they've got certain policies and procedures in place. If it's hosted in the Rackspace cloud, it's probably going to be subject to different controls than something in a dedicated, hosted as a dedicated server. And so, knowing where these things are hosted is important from a standpoint of what governance and controls can I expect in these environments. And from a testing standpoint, what level of testing or what testing activities would I even be able to undertake if I wanted to learn more about the security of the system, right? Is this something where I can go and do whatever testing I want? It's in my data center as long as I don't aggravate our corporate policies. Or is this something where the cloud vendor is going to have some opinions about the type of testing that can be done, right? Can I test this? What if I test something that's going to potentially spill over into someone else's data? Nobody probably wants you doing denial of service testing, and so that's again, these are very important things to understand. But Dan, you might say, that sounds like a threat model, or at least a pretty good portion of a threat model. And I would have to agree. It's pretty much a threat model is understanding what are the pieces of the system, how are they talking together, and that's then going to inform when we look at the security of the system, and especially when we do security testing, that's going to put us in a better situation. That knowledge is going to put us in a better situation where we can characterize the risks associated with any vulnerabilities or issues that we find. So just really speedy here from a high level threat modeling process. We got to decide on scope, what's in scope and what's not in scope. I think Tanya made a great point in her talk where people say, well, these microservices aren't in scope, and they're like, they're in scope for bad guys, right? They're in scope for bad guys. What is the rationale behind leaving them out of scope for this testing? You build your data flow diagram so you understand how the pieces fit together. Like the steps 1 and 2 are really what we need for this architectural bill of materials, but then when we look at, well, how do we enumerate the threats and how do we decide on mitigations, right? Those are the things that you're ultimately going to have to be able to speak to when you, when you're reporting or characterizing the risk associated with anything you find. So it may make sense just to get those out of the way at the current time. Again, I still like, there's different approaches. I don't know if anybody had the opportunity to do the free threat modeling sessions either in the morning or afternoon yesterday. I heard those were really good. A lot of stuff out there about threat modeling. I still, again, like the Jordan DeMarco data flow diagram type stuff. Where you enumerate, here are all the different pieces of the system, here's how they're talking to one another, and then identify the threats to that data flow, right? So if I have external interactors, hey, how am I concerned about them spoofing? How am I concerned about repudiation for actions they may or may not have taken? For data flows, how am I concerned about people tampering with the information coming across this data flow, or unauthorized people getting access to the information, or someone being able to stop that data flow? And so on and so forth. And so, again, take all the assets, associate the threat types with an asset, and voila, you've got a list of things that you need to worry about, which is also really handy from an assessment targeting standpoint. It gives you a starting list of the type of things from a design and architecture standpoint that you probably need to incorporate into the way that you're planning to do your testing, the way you're planning to do your assessments. So again, for the architectural bill of materials, we need at least results in step 1 and 2. It's a situation where you probably want to finish those things off because you're going to need the rest later to provide context for reporting. So given the architectural bill of materials, we need to basically go through, and now we have the list of the pieces of the system, and now we need to figure out what are the security tasks that we would undertake. What are the assessment tasks? What are the testing tools we might use on each piece in order to understand the security of the individual pieces? For that, what we look at is what I call, after the A's and B's, is now the 4 C's. The code. What code did we write that is running in this part of the system? Components. What are the components that we've rolled up? Code that we didn't write but that is impacting the security of the system. From a compute standpoint, like what type of, from a processing standpoint, an operating system, like how's this code actually being run? And then the cloud configuration, what cloud assets wrap this that we didn't write or we don't control, but that make up and have an input on the security of the system. Code. Again, this is the code you write. This is the business logic that makes your application do whatever stuff it is that is valuable to your organization. Also the glue code that you use to attach to other stuff. And this is really looking back through my history with OWASP, or having interacted or worked with OWASP and participated in OWASP for 15 years or so, a long time. Now this has been the traditional focus of OWASP and the traditional focus of application security. All right, I wrote some code, tell me about the security of the code I wrote. And you can do automated testing for these, with your static analysis tools, with your dynamic analysis tools, now with your interactive application security testing tools. And this is also, typically the focus of your manual penetration testing and manual code review, right? And so the code stuff is really looking at, again, like what OWASP did for the first 12 or so years, or 10 or so years, looking back through the history, this was really the focus, right? And that was, groundbreaking at the time. It wasn't something that a lot of organizations were looking at, and I would argue that, this is still an area that has not been solved. Some organizations, very mature, doing very well. Other organizations, lag behind, are just now realizing that the code they write, it's not just the servers they deploy, but the code they write exposes them to weakness. And so, in a lot of ways, a frightening thing about this, or a frustrating thing from a security standpoint, is even this wasn't a solved problem. And now the problem is being made significantly more complex, and so that's again a frustrating aspect of this. But again, nobody, the world doesn't necessarily care about your feelings. It's something that you've got to find a way to deal with. What further makes this a little more aggravating or interesting is the API testing, right? Now a lot of these communications, even on the web front end, it's single page applications that are talking back to services. If you look at things talking behind the web front end, those are also potentially microservices, and a lot of the traditional dynamic testing tools don't necessarily have a great answer for API testing. The Zap folks have some interesting capabilities they've developed in this area. A couple of the commercial vendors have made that a priority to say, we need to be able to do directed fuzzing on these APIs, but it's not something that is spread entirely across all the players in the space. And so all the code testing that you were just getting your kind of mind wrapped around before, and you just kind of felt like you had your vendor mix locked in, the world might have shifted out from under you for new applications that are going to be developed in your organization. Next we look at the components. So how do all these, what are all the additional things that we snap together that are going to support the code that we've written? These are typically open source components, and again, I love open source components because that means that I don't have to write a lot of code, right? Just from an economic standpoint, it's not, it'd be preposterous to say we're not going to use any open source. I always enjoy, again, as a software vendor, we get questions from purchasing departments like, do you include open source code in your application? I'm like what world do you live in, right? How much software have you bought in the last whenever that where there's where nobody's using, where there's no open source code, unless you're doing some real wacky focused embedded stuff. That's simply not the case for any organization that we've dealt with or our stuff. Was there a question?
So with components, do you consider license risk, especially with all the open source you're talking about? Is that part of the bailiwick that is AppSec?
Great question. So the question is do I consider license risk to be rolled up as an AppSec concern? I typically see it as a very important concern, but one that is orthogonal to what most of the application security folks care about. That's something that purchasing tends to care about. It's something that legal tends to care about, compliance. From an AppSec standpoint, I usually try to kind of throw that overboard. Again, as a software vendor, we certainly care about that. But when we're working with organizations and working with security teams, they typically view their mission as dealing with the risk of breach, and it's someone else's concern to worry about the license risk. And there may be shared activities. Again, a lot of the commercial players in the space will do your license audit while you're doing your, and so it's kind of a dual use. Most AppSec teams that I can think of, certainly not universal. I can think of cases, but typically it's a corporate or a legal policy that is then pushed down to the dev team. The app security folks are looking at one thing. It's a related activity, but at the end of the day, there are different stakeholders. But that's an excellent question and gets to some of the stuff I'll talk about in a couple minutes about reporting and how do you characterize these things. Because again, if I'm going to the development team, as a security person, I'm saying like, trust me, you really don't want this version of struts in your application. I assure you, right? Whereas legal might be coming to them and saying like, hey, in this packaged software that we sell, like this AGPL or this GPL3 stuff that you put in there, like we need to find a workaround for that. Typically though, I see those as orthogonal concerns. That's really a good question though. So this like component stuff really gained prominence again about 6 years ago when it got included in the OWASP Top 10 in 2013. So it really gained prominence. There were some commercial vendors that were very excited to have that included, which is kind of what it is. But as we've seen with things like the Equifax breach, we've like seen situations where it is certainly a very valid concern. So thank you, Struts. Struts is like the salesperson of the year for XYZ software composition analysis vendor. I'm sure they love the Struts folks. So how do you test for this, right? Typically you're going to test with some sort of a software composition analysis tool that's going to watch the build, see what are the components that we pull in, what are the dependencies that get pulled in, let's check the versions that are being pulled in, and then check those versions against a list of the of known vulnerabilities. And then the more sophisticated ones will go in and say, hey, based on some control flow or data flow analysis of the code, does it look like the use of this component in this application puts you in a situation where you're using those vulnerable functions? And this is, again, very much related to the traditional software bill of materials scope. And I really encourage folks who maybe don't have any sort of practices in place. A great way to get started is to use like OWASP dependency check. And it would be helpful if I was on the slide that had all the things that we were talking about there. And these are all be online and all that. So for components. So you've got your code, you've got components. The next question is like, what's running all this code, right? Like, somewhere there's a processor that is like, moving zeros and ones around and making decisions and branching and doing stuff. Something has to run all that code. And in the current environment, that can be things like virtual servers. It can be virtual machines. It can be cloud servers, containers, very popular. Serverless also takes this to the extreme, right? Where's the compute? I don't know. That's totally not our problem, and that's fantastic. And as we've learned from earlier, don't forget about our good friends, the dedicated servers. And how do you test this? You test these depending on the configuration. You can test them with more traditional vulnerability scanners, Qualys, Nessus, Nexpose, and with newer technologies like the container vulnerability scanning or the container container scanning that looks for known vulnerabilities, misconfigurations, known like malicious containers and things like that. And so two different kinds of tool sets that are at different levels of maturity and modernity. Depending on like what are you actually relying on to run this code that you have. And then finally, our fourth and or fifth C's are the cloud configuration. And I'll be the first to admit this is the squishiest of all the C's, right? Maybe that's why it gets two C's. I don't know. And right now, this is largely configuration checks, right? Because the question is, for the cloud environment that is surrounding this, what are the configurations? What are the configurations of how these cloud components are set up? What are things supposed to be able to talk to? How do they handle? Identity and access management. Do you have things like very well-known issues like OpenS3 buckets, right? And this is something that I very much see evolving over time. If this presentation were given a couple years ago, cloud servers might fall into this type of category just because of a lack of understanding of how those worked versus other servers. Again, if I give a similar talk to this in 5 years, maybe we'll have an additional C, as things become more stable to say, okay, well, we've got these very well-known specific cloud services, and these have become central enough to the way that organizations are deploying applications and consistent enough. Maybe this would be something where we look and say, oh, okay, we've got like an entire new assessment methodology, set of tooling around how we do. Again, XYZ, hosted MongoDB or whatever that might be. And so this is, again, kind of the squishiest. And right now, a lot of the tools in the space are really doing configuration checks to say, you've turned on some sort of a cloud-based thing that's going to be a part of this application. What are the rules that for the controls that you have the ability to enforce there? What are the rules that you have put in place for how that thing should, how that thing should behave? So what does this all look like? I provided this illustration to our marketing team and they wept, right? Because the way I think of this is you've got your code, which is a bunch of silly putty, and it's sitting on top of some Lego bricks that have been snapped together, and that's and those are the components, and that's an analogy I stole, I think, from Jeff Williams, who's speaking, I think, tomorrow. Certainly check him out if you have the opportunity. But so we've got a bunch of silly putty that we have a lot of control over. That sits on top of some Lego bricks that we have to snap together, but don't really have as many choices of the configuration of. That all is being driven by some sort of an engine that is the compute, and then that runs on tracks that have different switches and things you can follow, and that's your cloud configuration. Again, I put that to our marketing team, like, you get it? And they were like, no, Dan. No, Dan, we're not going to make a pretty graphic of that for you, so you get my drawing. So I'm still, I think I'm still trying to figure out, like, how do we, what's a better way to to conceptualize or think about this? That really crappy way is currently my best of breed thinking. Again, happy to take suggestions later on, or if someone is a better artist than me and wants to make that look better, you're more than welcome to do that as well. And so, what we're looking at from an assessment standpoint is, what are all the different pieces? And what are the security characteristics of each of these individual pieces, right? Based on code, components, compute, cloud configuration, and then given the interaction of those components, how do those interactions potentially characterize the risk that we're going to face from the vulnerabilities that we find? And from a reporting standpoint, I think it's really important to understand your audience, because it was hard enough to characterize in a monolithic app environment, here's what, hey, we found this vulnerability, here's why you need to be scared about it and how much you should be scared about it. In an environment where you have multiple players, multiple pieces all talking to one another, like, that gets even more challenging to characterize. Well, in order to exploit this, they would have to find this, which means they'd have to go through these steps. Then to exploit it, they would have to have this window or whatever. I think it's gotten a lot harder in more complex applications to characterize, for weaknesses that we found or for vulnerabilities that we've found, what are, like, how do we characterize this? And so, I think it's important to understand who are the consumers of what you're trying to, who are the consumers you're trying to communicate with? Is it security and risk management folks that are going to understand at a security level these vulnerabilities? Is it individual service owners or developers that maybe don't have a great idea of what they're doing, how that rolls up into the big picture? Again, that's something you need to be aware of, and this is where that architectural bill of materials comes in handy, because you can show, here are the different pieces of the system, here's how they fit together, right? Here's the bad guy, here's the steps they would go through to get to this, right? And here's how we're going to characterize, here's why we're worried about this, and here's how much we're worried about it. From the security and risk management folks, there's different models for that. Risk equals the impact of an incident times the likelihood of that happening. Again, likelihood is something that I think has gotten a lot harder to characterize in these cloud-based systems or cloud-native systems, just because of the complexity of the architecture. I'm still a fan of Dread. No one else is. That's fine. Or a lot of organizations use the common vulnerability scoring scoring system, version whatever, version 1, version 2, version I think 3's coming out now. Where you have here's our base metrics about this vulnerability. Here's like at its core what the problems are or the risks are with this vulnerability, and from the environment that this vulnerability can be found in, here's a way to characterize that. I think that's helpful in a lot of cases. And a lot of times there's a narrative, right? So if A, then B, then C. And again, like, what are you trying to communicate here? Your base concerns for the risk for the exposure, any compliance impact that might have, any impact on service level agreements that you have with customers. Looking at service owners, looking at developers, why should they care or why do they have to care? I've said it before, I'll say it again. I think that from a curmudgeon point of view, there's a perception that developers don't care about security. I have not found that to be the case in the vast majority of my interactions. I find that developers care about security, and lines of business care about security. They care about risk, but they also care about meeting deadlines, fixing non-security related bugs, and a host of other things that are not often on the radar of security folks. And so, to characterize, why is this something that you may need to care about, and why you would choose to take action on this over something else. And also characterizing, how do I fix this, right? It's one thing to go in and drop a PDF on somebody's desk and be like, wow, you must not be very good at developing because we found all these problems. And that is satisfying. But if you want to get invited back, and if you like your car not scratched up, you probably want to come with a little bit more of that. And I think that's something that I've seen from OWASP that I really like about the OWASP community, is a focus on not just on look at how elite I am and how I pwned your application. There's also a lot of focus on, hey, how do we prioritize these and how do we come to the developers with something so that we're not just bringing them problems, we're also bringing them, if not solutions, then at least the building blocks for solutions. Another challenge with with testing these cloud native applications is you have to make tough decisions about what activities you want to undertake and which ones you don't, right? Anybody here, everybody, most of the folks here work in security, right? How many people have all the resources they want, right? They've got all the team members they want, right? They've got like all the tools they think they need to do their job right. They've got all the time, like no crunch schedules, not having, right? I'm waiting for the organization that feels that way, and I'm going to submit a job application immediately after I find them, right? So nobody has all the resources they want. That's just the nature of security. I mean, it's the nature of life, right? I mean, that's just like economics is like, how do you use incentives to drive decisions? And if you come in with an attitude of everything is important, well, if everything is important, then nothing's important, right? If you can't prioritize and say, of the 10 things we've got, these 3 are important, these 4 I kind of care about, and I'm willing to let these 3 just die on the vine because realistically we're just not going to get to that stuff. So you've got to ask questions. Of the parts of our architectural bill of materials, what services are dealing with the most critical data? Which components of the system, just because of architecturally where they sit, expose the application and the underlying data to the greatest risk, right? Are you more concerned that a container that nothing should be able to connect to has a blank root password? Or are you possibly more concerned that your login routine has a cross-site scripting vulnerability exposed, right? So which type of vulnerabilities are really going to be the ones that cause you to take action? Or when you do your reporting to the risk management folks, when you do your reporting to the business or the developers, would be the ones that you really highlight, because that's where you need to prioritize. So depending on your architecture, maybe you say, hey, anything that is public facing, all the public facing web stuff, public facing APIs, that's what the bad guys see. They're going to be able to do dynamic testing. Maybe I want to prioritize dynamic testing of those because that's going to replicate most accurately what an attacker is going to be able to do. Maybe you want cloud configuration checks, right? You say, you know what, these developers are new to using the cloud, and they're using stuff they're not familiar with. Let's see if we can run some configuration checking to identify, are there S3 buckets that they didn't know about or that we didn't know about, right? Are there like identity and access management capabilities that should be in place but they just didn't know about them, right? So you can make decisions like that, and you've got to prioritize the activities based on the resources you have available. So for example, if we go back and look at this media site, right, web front end, a couple of web services, some S3 buckets, Amazon Aurora database, hosted Mongo, and our my kind of humorous example is the dedicated chat server. What's the attack surface? Well, definitely known is going to be the web front end, and trivially able to be identified to be the chat server, and depending on what it's doing, maybe the hosted MongoDB. What's your additional exposure, right? We want to look at all the exposed network assets that we've got, any IPs that are facing out, in the cloud configuration. Are there parts of the system that maybe we didn't know about? So we're going to establish assets to establish this architectural bill of materials, do our cloud configuration check to find out, are there any weird parts of S3 buckets we didn't know about, or gross access management sins that have been committed, network scan of any exposed IPs, but the ones where we have control or we have the authority to scan those, right? That's something we talked about earlier. In a cloudy environment where different players own different parts of the system, your testing rights are potentially limited. Dynamic scan of the web front end, maybe some manual penetration testing depending on the budget, and let's take a look and see if we can do some fuzzing against the chat server, and again maybe some manual penetration testing, because again that's going to be part of the system that maybe we don't know a lot about, but we do know it's going to be something that's easily discoverable by somebody looking through and seeing how the site works. If you have more resources, maybe you'd make a decision to do manual testing of the web front end, more manual testing of the chat server. Maybe do some dynamic or API scanning of the microservices supporting that web front end. Maybe do some static analysis, manual code review of the web front end or those services. Interior network scanning so that you don't have your cloud native app that's crunchy on the outside, right? For what perimeter you actually do have in this environment. Or what perimeter you think you have. Maybe you also want to do some interior scanning if as it turns out, your perimeter is nothing like you thought it was. Maybe you start looking at some container images, looking for malicious images, misconfigurations. And maybe you can work with the vendor of that MongoDB service to see, hey, let's talk about what you won't allow us to do testing, but let's see what sort of security assertions that you can make about your environment. Again, like your list may vary, but that's I think a really important thing is to recognize in an environment like this where the number of pieces of the system has exploded, has really proliferated, and the parts of the system that you potentially would want to check has also expanded. You're going to have to make some potentially really tough decisions, knowing your resources about like, hey, this is the first pass we're going to do. This is what we're going to do because we think this is going to find the scariest stuff the fastest, and then after that we'll look for additional resources or reprioritize based on what we find or based on the resources we have available. Yeah, so I've got, and let me think if you give me a card, or I'll see if I can find a way to find this. Actually, at LASCON last year, I talked about the threat modeling specifically for IoT devices, and medical was a subcomponent of that. And so I think that fits very much into this model, because what you're going to see is, again, from a bill of materials standpoint, we've got a device, it's running code, it's talking, potentially, it potentially has attack surface from Bluetooth for updates and all this other stuff. It may be talking to some sort of central services that are collecting data. Those are then feeding that to the big data engine or something like that. And so the same process works. It's a question then of that device is just another thing that feeds back into, or it's another part of your architectural bill of materials. And again, there's for medical devices, if you look at doing testing for those, it's a little more kind of specialized or focused just with the protocols that they speak, and especially when you're looking at safety critical systems where hey, if this heart monitor decides to somebody decides to SQL inject the heart monitor, then there can be a death or some sort of a health impact. So I would say that this I think everything I've talked about today fits that, and I would say for medical devices there are some additional concerns just because of the safety criticality and because that tends to be a somewhat more specialized area of testing. And if you give me a card, I've got some resources that I can send you that talk about that kind of more specialized area. So that's a great question. So the question is, if you're a cloud provider, would the thinking about this change? I think as a cloud provider, and again, if you want to talk afterward, I can provide a little more specifics about this. But as a cloud provider, I think the important thing is to recognize that you're providing those fundamental building blocks. And so you have the same responsibilities that anyone has building a line of business application, right? Your cloud's going to have pieces, it's going to have a threat model, architecture, bill of materials, but you also have the responsibility to provide those fundamental security controls and capabilities and expose them to the consumers of your system, right? So if you're making I don't know where you're working. If you're making a product that's, for example, called S4 buckets that people can use for block storage, or something else like that, in addition to looking at the security of the system, there's also an engineering, an engineering for third-party use component that gets layered on top of that as well to say what security controls and configuration are we going to offer, and how are we going to expose that? How are we going to expose that to people that are consuming our service so that they can, so that they can say, well, here's the identity and access management controls that we want. Here are the ways that I want things to be able to talk to one another using this building block service that we've created. Well, thank you all very much. I'll be around for a while, and appreciate it.